Okay guys, this is Motion Vocabulary 1. Feel free to pause this as you need to get the definitions and pictures down. But I would recommend listening to the explanations because we're going to use these with mathematics in the coming days. Alright, so first up is position. This is pretty easy. This is the place where the object currently exists. So this is where you're at currently. It's where you're at, right? We need to know this. Usually you see this on like Cartesian coordinates. So x, y, so the idea of like having an xy plane. So xy axis, like we're going to think about this where it's at on the Cartesian coordinate. Like the Google map, the position would be the little red pin balloon thing here. Okay, time measured in t, or the symbol is t, measured in seconds usually, s, seconds. Measurement between two events, usually measured in seconds or minutes or even hours. Here's a clock. All right, motion, now going back up to position where you're at, motion is a change in position. So the symbol for change is this Greek delta. You're going to see that a lot. That means change in position. So change in position. The frame of reference over time. So usually we look at change in position over time, and you can look at motion diagrams. So let's say each snapshot is a second. This would show something changing every second at about equal intervals. So it's going about constant speed. Right. Now this is important here. Scalar quantity. Quantity just means type of measurement. Type of measurement. Okay. So the word quantity does not mean number. It does not mean number in physics. It means a type of measurement. So scalar means a number without a direction. So examples of this are going to be, as you see in a minute, speed, distance, temperature, things like that. There are things that you don't typically need a direction at the end of it. So you get in your car, it says 10 miles per hour. It never says 10 miles per hour north. Or if it says distance, you didn't say you went 10 meters west. Temperature, it's not 100 degrees south outside, right? Okay, so if you don't need a direction, if there's no direction attached to the measurement, then it is a scalar quantity. All right, vector quantity, on the other hand, is the opposite of that. It's a number with a direction. This is going to be, as you see in a minute, displacement. This is going to be velocity. This is going to be acceleration. And as you see in the next chapter, force. Okay, you're going to see force in it. So these values, when you give a number value, you need to make sure you have a direction with it. So if you were displaced 10 meters, you need to say 10 meters north, south, southwest, southeast, something like that. You need to have a direction. Velocity, kind of like speed, but instead of like 10 miles per hour, you have to say like 10 miles per hour north or 10 miles per hour southeast. And they're usually going to be measured in meters per second in this class. All right, here's an example of the difference between distance and displacement, right? So we have distance here, and we're going to compare it to displacement as a vector and scalar quantity, okay? So distance, the measure of length between 2 points. So here we go. Usually measured in meters or kilometers. So let's say that this first distance between these two positions is 4, and the distance between these two positions is 3, okay? So we have 4 meters and 3 meters. Okay, so what would the distance be if you added those up? That would equal 7 meters is our distance, right? Okay, now, but let's look at displacement. Displacement, on the other hand, okay, I'm going to have the exact same setup between these first two positions, 4 meters. These two is going to be 3 meters. Our displacement, though, would be the distance an object moved from the starting point. So if this was our starting point, A, all right, this was our starting point, A, this is B, and this is C, and I had 4 meters, 3 meters, this right here would not be a displacement of 7 meters, okay? This would actually be displacement of, and if you use the Pythagorean theorem, because look, we have a triangle now, this would actually be a displacement of, and I'll show you how to do this in the coming days, but just for now, take my word for it, this would end up being a displacement of only 5 meters, okay? This is displacement. So that's how you do displacement, right? Use Pythagorean theorem on a triangle, or you could simply, we'll get to it in the coming days. But for right now, what you need to know is that's the difference between a vector and a scalar quantity. Now, this would be a displacement of 5 meters, and where did we go? We went to the never eat sour watermelon. So we went to the east and north. So this would be a magnitude of 5 meters, and the vector would be northeast, right? So this is the correct way to get the displacement since it's a vector quantity. All right, for the next video, we'll go over these terms down here.